Today let us solve few problems related to mole concept. For this, first we must remember few formulas, and I have listed few formulas, and these are the formulas which are used to calculate the number of moles. You can calculate the number of moles of atoms or number of moles of molecules. Let us go through these formulas one by one. First formula is number of moles of atoms is equal to mass by gram atomic mass. When we must use this formula? This formula must be used when the mass of an element is given and you are asked to calculate the number of moles. For example, how many moles of sodium atoms are present in 2.3 gram of sodium? See here, sodium is an element. Mass of an element is given, so 2.3 gram of sodium, and you have to calculate the number of moles of sodium atom present. So in that case you must use this formula. When the mass of an element is given and you are asked to calculate the number of moles, you will use this formula. Here what is the mass? 2.3 gram of sodium. So divided by, what is the gram atomic mass of sodium? It is 23. So number of moles of sodium atom will be equal to 2.3 by 23. So this formula is not only used to calculate the number of moles. This formula can also be used to calculate the mass of the element if number of moles of atom is given. See, in all these formulas what you must do is, you must see how many terms are there. Here in this formula there are three terms. One is number of mole, second one is mass, and the third one is gram atomic mass. Out of these three, if any two is given, the third one can be found out. If the gram atomic mass of the element is known to you and the number of moles of atom is given, then you can calculate the mass. If mass is given and if you know the gram atomic mass, you can calculate the number of moles. Same with all these formulas. Second formula is number of moles of molecules is equal to mass by gram molar mass. So when you must use this formula? This formula you will use when the mass of a molecule is given or mass of a compound is given and you are asked to calculate the number of moles of molecules. For example, how many moles of carbon dioxide is present in 11 gram of carbon dioxide? Then how you will calculate the number of moles of carbon dioxide molecules present? 11 divided by the gram molecular mass of carbon dioxide. You know how to calculate the gram molecular mass. So gram molecular mass of carbon dioxide is 44. So 11 by 44 gives you the number of moles of molecule. And the number of moles, this mole is denoted by the symbol N. So number of mole is denoted by N. So in this chapter, wherever you come across the small letter N, this indicates the number of moles. Third formula, number of moles of gas is equal to volume of gas at STP divided by molar volume. So you will use this formula to calculate the number of moles when volume of a gas is given. For example, how many moles of carbon dioxide is present in 200 cm cube of carbon dioxide? See, 200 cm cube, dm cube, liter, these are the units of volume. So how many moles of carbon dioxide is present in 200 cm cube of carbon dioxide? Then you will use this formula. Number of moles of gas is equal to 200 divided by molar volume. What is this molar volume? Molar volume is the volume occupied by 1 mole of a gas at STP. The volume occupied by 1 mole of a gas at STP. What is STP? STP is standard temperature and pressure. The standard temperature and pressure is called as STP. The standard temperature and pressure is a temperature of 273 Kelvin and a pressure of 1 atmosphere or 1 bar. This temperature and this pressure is called as STP. At this temperature and at this pressure, you take 1 mole of any gas, it will always occupy 22,400 cm cube. So the volume occupied by 1 mole of a gas at STP is called molar volume, and the molar volume of any gas at STP is 22,400 cm cube. If you convert cm cube to dm cube, then it will be 22.4 dm cube. 1 dm cube is same as liter, therefore either it is 22.4 dm cube or 22.4 liter, but when it is in cm cube you must use 22,400 cm cube. Now how many moles of carbon dioxide is present in 200 cm cube at STP? Then 200 cm cube divided by molar volume, it should be 22,400 cm cube, because volume is given in cm cube. So you must use 22,400 cm cube. If the volume is given in dm cube, then you must use 22.4 dm cube. If the volume is given in liter, then you must use 22.4 liter, provided the volume must be given at STP. If it is not at STP, then we must convert it into STP. Let us see by taking few example problems how to convert the given volume into STP and find the number of moles. And the fourth formula is the number of moles of atoms is equal to number of atoms by Avogadro number. When we will use this formula is when you want to convert the number of atoms into moles. For example, how many moles of oxygen is present in 2.03 into 10 to the power 24 oxygen atoms. See, number of atom is given, and when atom is given and you want to convert it into number of moles, then you will use this formula. And you know Avogadro number, the number 6.022 into 10 to the power 23 is called as Avogadro number or Avogadro constant, and it is denoted by capital letter N, sometimes capital letter N and subscript A. So Avogadro number is the number of particles present in 1 mole of a substance, or it is the number of atoms present in exactly 12 gram of carbon 12 isotope. Once again I will repeat, the number of atoms present in exactly 12 gram of carbon 12 isotope is called Avogadro number, and its value is 6.022 into 10 to the power 23. The number of atoms that is present in 1 mole of any substance, how much? It is 6.022 into 10 to the power 23. This number 6.022 into 10 to the power 23 is called Avogadro number or Avogadro constant. So when number of atom is given and you want to calculate the number of moles of atoms, then you can use this formula. Similarly, when number of molecule is given and you want to convert them into moles, you can use number of molecules by Avogadro number. So how to remember these formulas? It is very simple. Here you see it is mass by mass, here also it is mass by mass, but here it is volume by volume, here it is number by number. So this is how you must remember, mass by mass. When mass is given and you want to convert it into moles, then it is mass by mass. When volume is given, you want to convert it into number of moles, then it is volume by molar volume. When number of atom is given and you want to convert it into moles, you will use this formula, number by number, mass by mass, volume by volume, and number by number. So these are the formulas which are used to calculate the number of moles. But once you memorize this formula, I can't guarantee you that you will be able to solve all the problems, because in this chapter there are varieties of problems and there are many problems, and here and there you will get confused, and the main confusion will arise because you will not know when to use which formula. So it is better you try to understand the concept, and once you understand the concept, you will be able to solve any varieties of problems, and you can solve n number of problems without any doubt. Now let us take few example problems and let us try to understand how to solve these problems using the formulas and concepts. First problem, calculate the number of moles of atoms present in 9.22 gram of sodium. So whenever you solve a problem, first you must read the question properly and you must note down what is given and what has to be calculated. Based on this, you must select a suitable formula, substitute, simplify, and you will get the final answer. Now let us read this question again. So calculate number of moles. So you must calculate the number of moles of atoms present in 9.2 gram of sodium. So you must calculate number of moles. In what? In 9.2 gram of sodium. So what is sodium? Sodium is an element or a compound or a molecule. It is an element. So when a mass of an element is given, how to calculate number of moles? Number of moles of atom is equal to given mass divided by gram atomic mass. So number of moles N is equal to, what is the mass? It is 9.22 divided by, what is the gram atomic mass of sodium? It is 23, and if you simplify, you will get it as 0.4 mole. So it's a very simple and easiest problem. First let us see few simple and easiest problems, then we will get into the complicated problems, then you will understand how to solve. So first you must read the question and see what has to be calculated and what is given. Based on that you have to select the formulas. It is very simple. Remember, if you want to calculate the number of moles, to calculate number of moles you must remember these three things. One is mass by mass, other one is volume by volume, third one is number by number. If mass is given, if an element is given, use this. If mass of a molecule is given, use this. If volume of a gas is given, use this. If number of atoms or number of molecule is given, then use this. So when you want to calculate the number of moles, use any one of these formulas. Let us go to the second problem. Calculate the number of moles present in 6 gram of hydrogen molecule. Once again, here you must calculate the number of moles. Present in what? Present in 6 gram of hydrogen molecule. So here mass is given, mass and hydrogen molecule. So when mass is given and when you must calculate mole, then the formula is mass by mass. Mass by gram molecular mass. What is the gram molecular mass of hydrogen molecule? Hydrogen molecule is H2. The atomic mass of one hydrogen atom is 1. So 2 into 1, it is 2. So the gram molecular mass of hydrogen is 2. Therefore, the number of moles of hydrogen molecule present in 6 gram of hydrogen molecule is mass, given mass, that is 6 gram, see 6 gram divided by the molecular mass, the gram molecular mass of hydrogen is 2. So 6 by 2 is 3. So 3 moles. Third problem, which is same as the second problem that we have solved. Calculate the number of moles present in 11 gram of carbon dioxide molecule. 11 gram. So you must calculate number of moles. That is what I said. To calculate the number of moles is very easy. To calculate the number of moles, if you remember these formulas, it is enough. That is mass by mass, volume by volume and atom by atom, you can solve the problem. If in a given problem, if you want to calculate the number of moles, then just see what is given. Whether mass of an element is given, mass of a molecule is given, or number of atom is given, or volume is given. Once you know what is given, then you can calculate the number of moles. So in this problem you see 11 gram of carbon dioxide molecule is given. So mass is given. So to calculate the number of moles, the formula is mass by mass. But whether it is mass by gram atomic mass or gram molecular mass, that depends on whether an element is given or a molecule is given. In this case, a molecule is given. Therefore, the number of moles of carbon dioxide is N is equal to, the given mass is 11, and what is the gram molecular mass of carbon dioxide? How to find the gram molecular mass of carbon dioxide? By adding the atomic mass of all the atoms present in carbon dioxide. So one carbon atom mass is 12 plus there are 2 oxygen atoms. So 2 into the atomic mass of one oxygen is 16. So 12 plus 32, which is equal to 44. 44 gram is the gram molecular mass of carbon dioxide. So the number of mole is 11 by 44. This is equal to 0.25 moles. See, very simple. Okay. Next problem. Look at the fourth problem. Calculate the number of moles containing 1.8 into 10 to the power 24 molecules of carbon dioxide. So what is given? The number of molecules is given. The number is given. You must convert them into moles. So when number is given, whether number of atoms or number of molecules, whichever. If the number of atoms or number of molecule is given, then the formula to calculate the mole is the given number of atoms or the given number of molecules divided by Avogadro number. So for this we must use the fourth formula. So number of moles is equal to number of atoms divided by Avogadro number. First you must always write the formula, then substitute. The number of molecule is 1.8 into 10 to the power 24 divided by Avogadro number. It is 6.022 into 10 to the power 23, and if you simplify, it comes around 2.99 moles. So when the number of atoms or number of molecule is given, the formula to calculate mole is number by number. the given number of atoms or given number of molecules divided by Avogadro number. So, you can use the calculator to simplify this, and by shifting the powers you get 2.99. Next problem, a similar problem. Calculate, yes, this is the fifth problem. Calculate the number of moles containing 1.204 into 10 to the 23 atoms of sodium. You must calculate the number of moles. Here the number of sodium atoms are given. So, when the number of atoms or number of molecule is given, you know the formula is number of mole is number by number. So, the given number of atom is 1.204 into 10 to the 23 divided by Avogadro number. So, that is n is equal to, the given number of atom is 1.204 into 10 to the power 23 divided by Avogadro number 6.022 into 10 to the power 23. So, 10 to the power 23, 10 to the power 23 will get cancelled. If you just divide this, you get it as 0.199 mole. So, number of moles is equal to 0.199 mole. So, I have taken very simple and easiest problems here. Whenever you must calculate number of moles, remember, when you must calculate number of moles, it is very easy. Only thing you must see is what is given, whether mass is given, volume is given or atom is given. Once you know what is given, you can calculate number of moles. Okay. Next, sixth problem. Calculate the number of moles in 44.8 dm cube of gas at STP. So, this condition is very important. 44.8 dm cube of gas at STP. So, what you must calculate? You must calculate the number of moles. What is given? 44.8 dm cube. Dm cube is the unit of volume. So, volume is given and you must convert it into mole. So, the formula is volume by volume. See, the number of moles of gas is equal to volume of gas at STP divided by molar volume. And since it is given in dm cube, the molar volume is 22.4 dm cube. So, number of moles is equal to, the given volume is 44.8 divided by the molar volume is 22.4 dm cube. If it is given in cm cube, then you must use 22,400 cm cube. Since it is given in dm cube, I am using 22.4 dm cube. If it is given in liter, you must use 22.4 liter. Okay, and provided the condition must be at STP. If other than STP, if the volume is given, then first we must convert it into STP. That we will see later how to convert the given volume into STP volume and then solve. Okay, here 44.8 by 22.4 is equal to 2 moles. Very simple. Let us take the next problem. Just a similar problem. Calculate the number of moles in 11,200 cm cube of carbon dioxide at STP. Any gas can be given, okay, provided this condition, and you must see the unit. If it is in cm cube, use 22,400 cm cube. If it is in dm cube, use 22.4. So, number of moles is equal to 11,200 divided by 22,400 cm cube. So, if you divide this, you will get it as 0.5 mole. So, this is how you will find the number of moles. The opposite is also fine, that is, if number of moles of atom is given and if you are asked to calculate the mass, then you can use this formula. So, the mass of the given element is equal to number of moles of atom multiplied to gram atomic mass. In the same way, if number of moles of molecule is given and if you are asked to calculate the mass of the given substance, then you can use this formula. Mass of the given substance is equal to number of moles of molecule into gram molecular mass. Similarly, if number of moles of gas is given and if you are asked to calculate the volume of gas at STP, then you can use this formula. So, the opposite is also fine. Okay, this is how you will solve simple problems. Next, let us take some complicated problems and let us see how it can be solved without using formulas or without taking help of any formulas. Magnesium are there in 3 gram of magnesium. So, you must calculate the number of atoms present in 3 gram of magnesium. From this unit you will come to know that this is mass. Mass is given and you must convert it into number of atoms. So in this question you see nowhere you see the word number of moles. So if in the question if you find number of moles, whether number of mole is given or whether you must calculate the number of moles, then you can use any one of that formula that we have used. But in this case you see there is no term called number of moles. So we can't use those formulas. Then how to solve these problems? Which formula to be used? Only thing that you must do is when you read the question, first try to understand what is given and what has to be calculated. Here the mass is given. This is how you must solve this problem. Mass is given and you must calculate the number of atoms. And you must know that this problem is based on mass and atom concept. Mass and atom. We know 1 mole is same as 1 gram atomic mass. 1 gram atomic mass of any element or 1 mole of any element contains 6.022 into 10 to the power 23 atoms. Similarly, 1 mole is 1 gram molecular mass which contains 6.022 into 10 to the power 23 molecules, which will occupy 22,400 cm cube. So now in this problem, since magnesium element is given, atom is given, we must use this. So we know this is an atom and mass concept. 1 gram atomic mass and atom. So 1 gram atomic mass of any element contains 6.022 into 10 to the power 23 atoms, and this is the standard. So first what we must do is you must take 1 gram atomic mass of the given element. Which element? It is magnesium. So 1 gram atomic mass of magnesium is how much? 24 gram. 1 gram atomic mass of magnesium is 24 gram. So 24 gram of magnesium will definitely contain 6.022 into 10 to the power 23 magnesium atoms, no doubt. So this is the standard. Now in 3 gram of magnesium, how many atoms are present? So number of magnesium atom present in 3 gram of magnesium is, just you must cross multiply. So you want x, so x will be equal to 3 into 6.022 into 10 to the power 23 divided by 24, and if you simplify this you will get the answer as 7.527 into 10 to the power 22 atoms. So first you must read the question and you must note down these two things. What is given? Whether mass and atom is given, or mole and atom is given, or mole and mass is given. So out of these two, if one of the concept is mole, then it is very simple to solve. If it is not mole, then this is how you must solve. And you must note down whether it is molecule, whether it is atom. So if it is molecule, then you will take 1 gram molecular mass of that given molecule contains 6.022 into 10 to the 23 molecules, and in the given mass how many atoms are present. So if atoms are given and if you want to find the mass, this is what you will do. This is what you will do. 6.022 into 10 to the 23 atoms means it is 24 gram of magnesium. Then in so many atoms, what is the mass? Is it clear? We'll take one more problem, then you will understand. Look at this problem. At STP, 0.13 gram of gas, 0.13 gram of gas occupied 180 cm cube. Calculate its molar mass. So from these units, from the units you must make out what is given. So gram, that is mass, and 180 cm cube, that is volume. So we all know that 1 mole is same as 1 gram molecular mass. 1 gram molecular mass is molar mass. Contains 6.022 into 10 to the power 23 molecules, and also it occupies 22,400 cm cube. So in this problem, it is a mass and volume concept based problem. So we must take these two, mass and volume. We know that 22,400 cm cube of volume is occupied by 1 gram molecular mass of any gas, that is 1 molar mass of any gas. In this problem it is given 0.13 gram of a gas occupies 180 cm cube, then calculate the molar mass. So 22,400 cm cube of volume is occupied by what? That is occupied by 1 gram molecular mass of any gas. So this will give you the molecular mass. So x is equal to 0.13 into 22,400 divided by 180, and if you simplify this you will get it as 16.18 gram. So this is how you will solve the problems. First you must read the question, and based on the units you must write this. First you have to find out this problem is based on what and what concept. This is mass and volume. So when it is mass and volume, we know 1 mole, 1 gram molar mass, 6.022 into 10 to the 23 molecules, 22,400 cm cube. So first you take the standard, first you must take the standard, then use what is given in the problem, then cross multiply, you will get the answer. So this is how you have to solve. We will solve still more varieties of problems at the end of this chapter. This is just a sample problems that I have solved. At the end of this chapter, once again we will take all the varieties of problems and we will try to understand the concepts clearly. Okay.